So in the last videos, I think we are discussing about bitwise operators. Okay, we are discussing about bitwise operators. I think we have seen very clearly how these bitwise operators are going to work. Okay, and coming to the applications, so I'm going to explain four applications for the usage of these bitwise operators. What is the first application is, so how to check whether the given number is even number or odd number? How you can check whether the given number is even number or not? Next, and after that, swapping of swapping of two numbers we are going to discuss by using this operator. Next, and after that, I mean by using these bitwise operators. Next, and after that, lowercase to uppercase, lowercase to uppercase conversion by using these bitwise operators, and uppercase to lowercase conversion also we can do by using these bitwise operators. Let us see these programs one by one. What is the first program? Even number or odd number? Sir, how to check whether the given number is even number or odd number? Already we have a Python program for that. Suppose consider n is equal to, we are going to take a number like input, and just if you pass the value of n as an argument to any function, or here itself if you want you can check if n percentage 2 is equal to 0. So can I say, is it even number or not? Yes. Otherwise, we can say the given number is nothing but what, odd number. Like that, we can able to do. But we know this logic already. We can simplify this logic by using bitwise operators. Best example, let us take the bitwise operators. I mean binary numbers. For 0, binary equivalent is nothing but like this we have. For 1, binary equivalent is nothing but like this. For 2, binary equivalent is 8421 code. For 3, binary equivalent is 8421. For 4, binary equivalent is 8421. For 5, binary equivalent is 8421. Like this we have. Can you please tell me what logic you identified here? So for the even numbers and odd numbers, after converting into binary, what logic you identified here? Can you please confirm? Do you find any logic here to check whether the given number is even number or odd number? Just to cross check by observing that binary numbers. Are you seeing any logic? Please confirm. Try to see all these binary numbers, whatever we have given. From that, for odd numbers and for even numbers, is there any differentiation? Observe carefully and tell me, sir. Bharat, can you please cross check?
And 2 power 0, maybe 2 power 1 is multiplied and added with the numbers there.
I have already given the binary numbers. Only see that 4 bits for every number.
Yes,
For
sir.
and
In
for even.
last, if
Hmm?
even number last में sir, in
Last,
last even number
yes, very
is last 0 and
yes,
odd
Yeah,
is 1.
yes. You can see for all the even numbers, the last bit is always 0. For all odd numbers, the last bit is always 1. So last bit in the sense, actually we will read from right to left. That's why that bit is called as LSB, least significant bit. If LSB is 0, then that number is even number. If LSB is, okay, if LSB is 1, then that number is odd. Like this, we can differentiate. Okay, if LSB is 1, then that number is even. If LSB is odd, if LSB is 1, then that number is odd. Sir, how you can deal with this? See, I'm going to take two numbers. For example, let us take 4 and then 5. If you take a number is equal to 4, its binary equivalent is 0, 1, 0, 1, 0, 0. Since you can see that last bit is 0, if you perform AND operation with 1, so what will happen? Definitely you are going to get 0. Then I can say it is even number. If you take number is equal to 5, what is binary equivalent? Like this we are going to perform. If you perform AND operation, then if you are getting non-zero value, then it is nothing but odd. Sir, how to do this? Very simple. Here you can take all zeros so that remaining values will become zeros. Now perform AND operation by concentrating only on the least significant bit. So in any binary number, if you take only for 1, the least significant bit will be 1, remaining all the bits will become 0. Okay. So on this basis, I am going to perform AND operation with the number 1. If your result is 0, then it is even number. If your result is non-zero, that is only 1 you will get, then we can say that number is odd number. So what is the logic behind this? Very simple. N performing AND operation equal to 0 means then so result is even. Okay. So else result is nothing but odd. So this is nothing but the logic what we have for this program. Is the logic is clear for you people? Please confirm.
Yes, sir.
Clear, right?
Yeah.
Right. So now we will convert this into program. Let us see how to do that. So we have taken a number. Here within bracket I am going to take n performing AND operation with 1. That's all. Now let us run the code and cross check whether this application is working or not. cd space I am taking test py space test.py. As you can see, it is expecting for the input. If the input is 4, then the output what we are getting is even. If your input is 5, the output what we are getting is nothing but what? Odd. Like this, we can able to check whether the given number is even number or odd number by using bitwise operators. When compared with normal operation, these bitwise operators are going to work a bit fast. Why? Because it is directly dealing with binary numbers. This is nothing but one application what we have. Similar to this, one more application is there, which is nothing but a swapping of two numbers. If you want to perform swapping of two numbers, I think in the demos I covered one example. Swapping of two numbers we can implement by using these bitwise operators. So if you want, you can see. Suppose consider a is equal to, I am taking the first number, okay, and b is equal to, I am taking the second number. So now I will print in a formatted string saying, so before performing swapping operation, a value is equal to a and b value is equal to b. Like this I am taking. So after performing swapping operation, you can see these. So how to perform swapping? So we have different logics are there. One among that is nothing but bitwise operators we can use. So that bitwise operator is nothing but we have cap operator is there, right? That we can use here. So how it is going to work? I will take one simple example and I will demonstrate. So for understanding this concept, let us consider a value as a 5 and let us take a b value as a 7. So what is corresponding binary equivalent? So 8421 is nothing but equivalent, and for 5, so 84, okay, 8421, like this we have. These are the two numbers what we have, a and b. Okay, a and b. These are nothing but two values what I have. Now I want to perform swapping operation. Please observe carefully. What is the first case is a cap b. A value is nothing but 0101. B value is 0111. Try to perform exclusive OR. Exclusive OR truth table we know very well. If you have 00, okay, or if you have 11, your result will become 0. If it is 01 or 10, your result will become 1. Exclusively OR. Then this 11 it will become 0, 01 it will become 1, 11 it will become 0, 00 it will become 0. So what is now latest value of a? Because we are assigning this to a, your latest value of b will become, a will become 0010. Now this one is completed. What is the second step? Again a cap b. So what is the latest value of a? 0010. What is the latest value of b? 0111. Now perform same cap operation. So 10 we are going to get 1 and here we will get 010. Sir, this is nothing but which value? the latest value of B like this we have. Now we are taking again A cap B. The latest value of A is 0010. Latest value of B is 0101. So perform cap operation. This will become 1. This will become 1. This will become 1 and this will become 0. So this value we are assigning to the A. So what is its decimal equivalent? Sir, is it 7 or not? Yes, what is its decimal equivalent? Is it 5? Initially 5, now it got 7. Initially 7, now it is 5. This is the way, by using bitwise operators, how you can perform swapping operation. I think you people got very clear clarity about this. Any doubts?
No,
No,
sir.
sir.
No. So let us execute this code and cross check how it is going to work. So now, sorry. So now I'm giving the input like so 10 and 30. So you can see before swapping 1030, after swapping 3010, like that we are getting. This is the way how you can perform swapping of two numbers by using these bitwise operators. What is the next logic here we have? So do you know uppercase to lowercase to uppercase conversions also we can do by using these bitwise operators. How it is going to do? Sir, it is a bit a tricky program. Please have a look once. I'm going to take a name from the user. So enter any name. Okay, enter any name in lowercase. We are going to accept the data in lowercase. I have to convert this into uppercase. So I'm going to take the resultant string, or s is equal to, or result is equal to initially empty. Result is equal to initially empty. So please have a look once, or you can go with do you know list also? You can take a list, empty list I'm taking. For each name or for each character present in the name, I will try to append that character into the list. At last, sir, I'm going to take space as the separator or empty string as the separator, I will join. In this case, what we have done, whatever string that you have given, as it is, we are printing. Okay, as it is, we are printing. So I think append of ch. Append of ch. I'm giving input as a Prakash. Same thing we got. So just I'm telling, I have a string is there like ABC if you have given. We are taking the first character and we are appending it to the list. While performing append operation, can you please convert that A perform cap operation with 32? Sir, it is a character, it is integer. How it is going to be? Better to convert this character into its ASCII format. What is the ASCII format for small a? Can you please tell me what is the ASCII value for small a? Is it 97 or not? Yes, 97 cap 32 we are going to do. If you perform, what operation we will get? Sir, let us see the conversion, sir. Let us see the conversion. So we need to convert that a value 97 into binary. Sir, how to get that binary value? Let us have a look. So we have x is equal to 0b. We are going to take 97. No. So we have 97 is there. bin of 97 I am taking. Sir, have you observed? This is nothing but the binary number what we have. Okay. So what is that number? You can able to see on my screen that number is nothing but what? 1100001. Like this we have. This is nothing but the binary equivalent of the number 97. And we have to perform cap operation with 32. So I think 8421 16 and then here 32 we will get. Okay, here we will get 32. That means here 1 will be there. So perform cap operation. So 1 and then 0. So we will get 1 and remaining places you will get 0. So here also you will get 0. Here you will get 1. Now what is its decimal equivalent? Sir, let me cross check again in the program I will do. So I am taking x is equal to 0b. Okay, 0b. Then 1000001. Now, what is the value of x? Is it 65? 65. Sir, you can check. So, is the given data, is converted into, so capital letter or not? Why? Because if you take 65, its ASCII code is nothing but A. So, the small letter value, lowercase alphabet value, we converted into uppercase alphabet. Sir, if the logic is clear, I will extract one by one and I will demonstrate. Sir, clear, please confirm. Up to this, do you have any doubts?
Clear, sir.
Clear, right? Yes, please confirm. Up to this, do you have any doubts?
Clear, sir.
Right. Now, what we have to do in this case, the same process, whatever I told, we have to repeat. So first I'm going to take one operation, like I will convert the given character into numerical form, and then I will perform cap operation with 32. Whatever result that you are getting, I am converting that result into character form. I am converting that result into character form. This entire thing I will append to the list. That's all. Your task got completed. Now let's run this code. Now let's run this code. Is it going to work? If the given input is a Prakash, we got in capital letter. This is nothing but what we have. Okay. Sir, lowercase to uppercase, how we are going to convert? You people got clarity. Now we have to see this reverse operation. What is a reverse operation? Uppercase to lowercase. We have an uppercase characters are there. We need to convert it into lowercase. Enter the name in uppercase. So opposite for this. Have a look once in the example. If I am giving capital ABC, okay, then we need to perform a OR operation with 32. What is the ASCII value for A? 65. OR operation with 32. What is the 65? This one is 65, right? 1000001. Cap operation with 32. Sorry, OR operation with 32. Okay, 000000. Like this we have. Now you can see 1000011. Sir, is it 97 or not? 97 means what? Small a. That's all. The only change is nothing but instead of cap symbol, try to take R symbol. Except that remaining things are same. Sir, is it working? Let me cross check. I'm giving the data in uppercase like Java. Is it converted into lowercase or not? Yes. This is the way how to convert lowercase characters into uppercase characters and how to convert uppercase characters into lowercase characters. Are you clear with these approaches? Whatever I told, please confirm.
Yes, sir.
Clear?
Yes, sir.
Right. These are nothing but the various applications of these bitwise operators. Still, we can go for so many applications, but in depth, I'm not going to take. Just at the top level, I'm going to explain. This is nothing but what we have. So with these bitwise operations got completed. Next, sir, I want to talk about dynamic programming. Okay, I want to talk about dynamic programming. Let us see what is mean by dynamic programming. So do you know DP? It is called as a dynamic programming. So when we can go for this dynamic programming in the sense, just have a look once, there are some problems with the recursion. To overcome that problem, we are going for dynamic. Sir, I can say the point. So it is the same as recursion. How recursion is going to work? In the same way it will work. But the advantage is nothing but recursion with optimized solution. Recursion with optimized solution is nothing but dynamic programming DP. Okay, recursion with optimized solution. Sir, why we have to optimize the solution? What is the problem here is, let us consider Fibonacci number program by using recursion. By using recursion, I'm taking this Fibonacci number program. Let's just identify. So I'm taking n value like int of input. So enter nth term, which term you need. Now I'm calling FIB by passing n value. If you take Fibonacci sequence, 0 is the first number, 1, 2, 3, 4, 5. Sorry. 1 second. So 0, 0 plus 1, 1, 1 plus 1, 2, 2 plus 1, 3, 3 plus 5, and then 8. Okay, like this we are going to get 13 and so on. Like this we are going to get. Suppose consider I have given the value of n as a input as a 5. I have given 5. Fifth digit I am expecting. So 0th number, first number, second number, third number, fourth number, fifth number. Your output is nothing but what? Fifth number we are getting. For this requirement, we have to write the code. So I'm taking a function called FIB integer n. So we know the general logic, right? If your n value is equal to 0 or if your n value is equal to 1, just we are going to return the value of n. Otherwise, what we are doing? We are returning FIB of n minus 1 plus FIB of n minus 2. This is the principle, right? What we have. Now let us see. Sir, is it going to give, if I'm giving 5, 5 is the answer. If I'm giving some fourth term, it is going to give 3. Is it correct? So if I'm giving something like 1, 2, 3, 4, 5, 6, seventh term, it should return 8. It should return 13. So 0th term, first term, second, third, fourth, fifth, sixth, seventh. Like this we are getting. Sir, this program already we implemented in our previous videos. Okay. But here just I want to demonstrate with the help of a small diagram, sir. Please have a look once. So since we are calling by passing Fibonacci of 5, what will happen? It is going to make a call to 2 times. One is Fibonacci of 5 minus 1, which is nothing but 4. So Fibonacci of 5 minus 2, which is nothing but 3. So this one again 2 method calls. 2 calls will be there. Here also 2 calls. 4 minus 1, 3, and 4 minus 2, which is nothing but 2. Here 3 minus 2, which is nothing but 2. Sorry, 3 minus 1, which is nothing but 2. 3 minus 2, which is nothing but 1. This one again it is going to call 3 minus 1, 2. So 3 minus 2, 1. Again this one is going to call 2 minus 1, 1. 2 minus 2, 0. Here also f of 1 will come and f of 0 will come. So here also f of 1 will come, f of 0 will come. Sir, total how many method calls? Sir, first method call, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th, 11th, 12th, 13th, 14th, 15th. If n is equal to 5, 15 times it is going to call. Can I cross check that? Yes, you can assign count is equal to 0 and at last you can print that count value. So what I am doing here, so I am declaring global C and C is equal to C plus 1. Now just execute this code. If you give 5, how many times, how many method calls we are going to take? Sir, 15 method calls we are going to take for this program. But my question is simple. So there is a problem with this code. Okay, so what is that problem? Is unnecessary method calls are there, sir. If you identify, sir, here you can see already f of 5, it is a new term. Okay, fifth term we are calculating. So next one is a new term, fourth term we are calculating. Next one is a third term we are calculating. Next term is a second term we are calculating. Next term is a first term we are calculating. 0th term we are calculating. Sir, now is it required to calculate f of 1? Already it is there. Can I reuse this? So this calculation is not required. So f of 2 already it is calculated. Can I reuse that? Yes. Sir, here also f of 3 already we calculated. We can reuse, right? What is a need to calculate again and again? Okay. So I am simplifying this algorithm like I will calculate f of 5, which in turn calculate f of 4 and then f of 3. So this f of 4 in turn calculate f of 3 and f of 2. F of 2. So this f of 3 in turn calculate f of 2 and f of 0. Sorry, f of 1. Then f of 2 in turn calculates f of 1 and f of 0. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 method calls are sufficient. Almost majority of the part. 6 calls we are reducing. So this is nothing but the concept of which one? Dynamic programming. To reduce the number of method calls. We can't apply this problem for every recursion based program. Something like if it is generating like this, a repeated method calls are there, like Fibonacci number, okay, or any other sequence like that when you are generating. If the output is depending on number of method calls, in such cases, happily we can able to go for which one? This is dynamic programming. So dynamic programming main intention is nothing but what? To reduce the method calls. Okay. So we can't apply this dynamic programming for every recursion based application. There are some limitations are there. You have to identify a proper problem which generates so repeated calculations, and then we have to apply. Sir, please confirm, is the main agenda of this particular concept, is it clear for you people? Please confirm.
Yes, sir.
Yes, sir. Clear.
Now, so we will see how we can able to implement this program. Okay. So we have to see how you can able to implement this particular thing, sir. For this, we have different approaches are there. Okay. For this, we have different approaches are there. We are going to use any one of the technique for solving this. Okay. Let us see what are the approaches that we have to solve this one. Okay. We have two methods are there. Okay. We have two methods are there. We can implement a dynamic programming. So by using the following two methods, what are those two methods is, first one is memoization. Okay, memoization means what? Sir, it is a top down approach which use the recursion, but we are reducing the method calls. Second one is a tabulation, try to maintain an array or try to maintain a list. Okay, so don't go for recursion. Okay, like that we have two options are there. We can implement by using any one of this approach. So now we are going to see this particular Fibonacci problem, how we can implement by using this memoization, and how you can implement by using this tabulation. Okay. Now, sir, the first one is what? We are going for memoization. Let us see how we can able to do that. 1 second. So here, example, here already we have Fibonacci number program is there. Okay, already we have Fibonacci number program is there. Sir, do you know what I'm going to do here is I will create a list. Additionally, I'm going to create a list. Yeah. So when you are making a call, we are going to create another list, empty list we are going to create. What will be the size of that list is nothing but how many elements you are going to store. How many elements are there? N elements are there. With n plus 1 element, I am going to create a table, a list I am going to create with n plus 1 elements. So a list will be created. Assume the default value is nothing but 0. The default value is nothing but 0. Like this I am going to set. Sir, now let me print that list. Suppose if you are asking 5, if you are giving input as a 5, sir, is it coming with 6 zeros? Yes, now it is okay. I created one list. I am going to pass this list as a parameter to the FIB function. So what this FIB function is going to do is, it will take this list. So whenever your n value is equal to 0 or 1, then it will calculate n. Okay. So then it will return n. And it will check, is the list of n is not equal to 0. Okay, is the list of n so is not equal to 0. That means if the value is already calculated, why you are calculating again? Can you please return f of n? Okay, can you please return so that list of n? Don't need to calculate. Otherwise, what we are doing, your L of n will become, so FIB of n minus 1 comma that list plus FIB of n minus 2 comma that list. Then at last try to return, okay, that list of n. That's all, sir. This is nothing but what we have. Now please observe carefully. First we will execute this step. First we will execute. Now I'm giving the number as a 5. Sir, previously how many calls we made? 15, but now 9. Previous output and this output is the same. But what advantage we got here? Very simple. First it is going to take a Fibonacci of the number 5. I will maintain a list. I will maintain a list with the first element, second element, third element, fourth element, fifth element, sixth element as a 0. Indexes 0, 1, 2, 3, 4 like this. First I am calculating f of a 5. Sir, is n is equal to 0? Is n is equal to 1? No. Is L of 5 is not equal to 0? No. Then you have to calculate. So L of 5 is equal to, what is the formula? So again it is going to call n minus 1. That means, can I say this one is going to call, so 5 minus 1, 4, and this one is going to call 5 minus 2, that is 3. For this again it will calculate. So 3 and then 2. So for this again it will calculate. So 2 and then 1. So for this again it will calculate 1 and then 0. So whenever you are getting 0, that will be updated with 0. Whenever you are getting 1, that will be updated with 1. Now calculate 2. So 0 plus 1. Is the 2 is already calculated? No. Then calculate and return that value. Then f of 3. Is it calculated? No. Add these two numbers and store and then return. F of 1. Is it required to calculate? No. Already it is there. Just you can return. Sir, what about f of 4? You have to calculate and then return. What about f of 2? Already it is calculated. Please return that value. So calculations we are trying to reduce. This is nothing but the concept of memoization. In the memoization, just we are reducing the number of recursive calls. Beyond that, nothing. Are you clear with this, friends? Please confirm. I request everyone to please confirm. Clear up to this?
Yes, sir.
Right. So the next concept, same thing, can't we calculate without recursion? Yes, because in the recursive more calls we are getting, so we can reduce that by using which method? Tabulation. Okay. For this, sir, simply we are going to call. Even no need to maintain a list also. Okay. So how it is going to work? Have a look once. It is not a recursion. Simple. I'm going to declare. Okay. I'm going to declare one new list with how many elements? 0 as the default value for n plus 1 elements. Then what we are going to do? We know the first number. First number is always 0. We know the second number. It is always 1. Try to take a loop for each I value in the range of second to n plus 1. So what will happen? Your L of I will become, can I take L of I minus 1 plus L of I minus 2? It is calculating recursively. That's all. I mean, it is repeatedly it is doing. At last we have to return L of n. So how it is going to work? Suppose consider in this example, the value of n is 5. So we are creating a list with all 5 elements as a 0. Like this we are taking. This is 0th location, first location, second location, third, fourth, fifth. So what is L of 0? We are updating to 0. What is L of 1? We are updating to 1. Now when I is equal to 2, what will happen? I am taking L of 2, which is nothing but L of 1 plus, so L of 0. So what will happen? These two we are adding. 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 Okay. So like this we are going to get. And how you can able to print that? Very simple. Whatever n value that you have passed, that index value we are going to consider and we will return the result. So, sir, first we can go for this one only. But in the recursion, this problem is going to give some bad impact. That's why we are going to solve this problem by using this dynamic programming. In dynamic programming, we have two ways are there. One is nothing but what? Tabulation. Another one is nothing but what? Memoization. We can apply any one principle for this approach. Okay. Friends, are you clear with this tabulation and memoization? Please confirm.
Yes, sir.
Okay. This is nothing but what we have about dynamic programming. Still, we have so many examples. Just based on this template, you can able to solve. Okay. So with these, so today I am going to close the session. So we completed bit manipulations and dynamic programming. Sir, tomorrow I am planning to take this priority queues. Okay, priority queues. Already tree data structure completed, right? That's why tomorrow I am planning to take a priority queues and heaps, both are same. So tomorrow I will demonstrate that. And Saturday and Sunday we have a class on this graph data structure. So maybe Saturday itself is sufficient. And then greedy algorithms I will cover on Monday. So then we can wind up. Maximum by the next week, Monday or Tuesday, I will close our batch. Okay. Right, sir. So thank you. I will upload the running notes within few minutes. You can download. Thank you.
Thank you, sir.